going to take a quick look at a couple examples of factoring a trinomial in the form ax squared plus bx plus c, where a is equal to 1. So before we get to really factoring the trinomial, let's take a look back at multiplying a couple of binomials. So let's say I have this problem here, x plus 3 times x plus 4, and what I'm trying to do is take that from factored form into expanded form. Well, one of the ways to do that is to distribute. So if you distribute x times x, you have x squared. X times 4 gives you 4x. 3 times x gives you 3x. And then 3 times 4 gives you 12. When you combine your two like terms here, what you have is x squared plus 7x plus 12. So starting from this form and expanding out, writing out in this form, that would be sort of expanding. Now what we're going to be taking a look at is starting out with a trinomial that is in this form and trying to revert it back to factored form, and that would be called factoring. So I want to take a look at some trinomials that are in this form where a is 1, and what I mean by that is that the coefficient of x squared is just plain 1. So we'll take a look at a few examples of taking polynomials from this form and factoring them back into this form. I'm going to start with the answer we had from this last one, x squared plus 7x plus 12, since we already know what it's supposed to be. So if my job is to factor this trinomial, the first thing I think about is what I want this to look like in the end. Trinomials, most of them can be factored, if they can be factored into a product of two binomials. So the first thing I'm going to do, factoring this, is set up my two binomials. And that's going to give me these two binomials where I know what I'm looking to do is fill in 4 spots. And the method we're going to use for this is what I like to call educated guess and check. So when I multiply these out, where did this x squared come from? Well, the only part of multiplying this out that the x squared came from is multiplying these first two terms together. So I know I'm taking something times something and getting x squared. Well, that is going to be x and x. It's the only way I can multiply two terms of a first power and get x squared. Now what I'm looking to do is fill out these last two with constants, with just numbers. So what these two are going to multiply out to be is 12. The only place that 12 came from is from multiplying these last two terms together. So I'm going to multiply two numbers, and the answer of that is going to be 12. I have a product of 12. So I'm going to say I'm going to multiply two numbers to get 12. But there's one last piece of the puzzle here. Where did that 7x come from? Well, when we multiplied out and distributed this x here and this times this, we got something x, and those got combined together. They got added together to get 7x. So these two terms, these two numbers, they have to have a product of 12, but they have to have a sum of 7. And one way to think about this is to set up just a table where you can list out pairs of numbers that will work. So I always like to start with these two and think about what are the ways that I can multiply to 12. I can multiply 12 and 1, I can multiply 6 and 2, and I can multiply 4 and 3. Those are all of the combinations that could go here and here, 12 and 1, 6 and 2, 4 and 3. The one that's going to work is that set of factors that also has a sum of 7. Well, if I put in 12 here and 1 here, that's going to have a sum of 13. So the middle term will be 13x. That's not what I'm looking for. If I put 6 and 2, the middle term would be 8x, so that one doesn't work. And if I have 4 and 3, that will have a sum of 7, so that one works. So this will factor to x plus 4 and x plus 3 because it's positive 12 and positive 7. If you multiply this out, you would have x squared plus 3x plus 4x plus 12, and 3x and 4x will combine to 7. Alright, let's take a look at another one. X squared minus 2x minus 8. I know I'm trying to factor a trinomial down to two binomials. So I'm going to set up my two binomials, and I'm going to put a spot in here for my terms. So I've got 4 spots I'm trying to fill in. So let's think. These first 2 terms are going to multiply to x squared, so I know that that has to be x and x. And when we're looking for an x as 2 numbers that have a product of -8 and have a sum of -2. So multiply to -8 and add to -2. So let's think about all the ways you can multiply to get -8. Well, if I had -8 and +1, that has a product of -8, and so does +8 and -1. Well, also we have 4 and -2 and -2 and 4, and that should just about do it for all of the factors of -8. So let's see what they have a sum of. We're looking for the pair that has a sum that adds up to -2. So -8 and 1, that's going to add to -7, so that's not what we're looking for. 8 and -1 has a sum of +7, not what we're looking for. 4 and -2 has a sum of +2, not what we're looking for. And -2 and 4 has a sum, oops, I switched those around, didn't I? That should be a -4 and a +2. So -4 and +2 has a sum of -2, so that's the one we're looking for. So x minus 4 and x plus 2 will be the factored form. And you can always check your answer by multiplying it back out. X times x is x squared, x times 2 is 2x, -4 times x is -4x, and -4 times 2 is -8, and combine those like terms, and x squared minus 2x minus 8. So I know by multiplying it out that it multiplied out to what I started with, so this is the factored form. Take a quick look at one more. So let's say we've got x squared minus, let's say 10x plus 24. Alright, so x squared minus 10x plus 24. So I know that I'm trying to multiply this out to be 2 binomials, so I'm going to set that up first. And I know because that is x squared that these first 2 terms have to be x and x. Next, I'm looking to list out some factors, what multiply. These 2 are going to have a product of 24, so 2 factors that multiply to 24. And they're going to have to combine, so they're going to have to add to that middle term of -10. So what are the ways I can get 24? Well, I can have 24 and 1. And really, I'm looking for 2 numbers that are going to have a sum of a negative number. So I need to multiply 2 numbers to be positive, but add to be negative, which means that if I'm going to multiply 2 numbers and get a positive answer, either they're both positive or they're both negative. So in this case, since they're adding to a negative, both of my terms here and here have to be negative. So -24 and -1. I could also have -12 and -2. Let's see, I could also have -8 and -3, and I can have -6 and -4, and that should just about do it. All of these pairs of numbers have a product of positive 24, so let's see the pair that adds to -10. So this one adds to -25, not what we're looking for. That adds to -14, not what we're looking for. -11, not what we're looking for. And finally, -10. So our 2 terms here and here, x minus 6 and x minus 4. And now that has been reverted to factored form.